So this question basically the actions for the if and for, basically it's a matter of counting the symbols. So here for make if node, then according to the first one should be the condition. So what number is the condition? 1, 2, 3. So condition is number 3. So this is $$ equals. So condition is number 3. Then the then statement list. So this is 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. So the statement list is going to be number 6, 7, 8, 9, 10. So it's a counting exercise, basically. Okay. And here, make for node of, for the for node, again, we need to count. So the first thing has to be the initial, which is this. So this is number 3. Then the condition, and the initial and the condition, and then the post. Yeah. So this is 3, 4, 5. The condition is number 5. Number 6, number 7. So this is number 7. Number 8, number 9, number 10. So the trick is to make sure that you count everything and you don't skip any of the symbols. And if you have worked on the assignments, then you should have enough practice on this. So you shouldn't get this wrong if you have been working on the assignments. Okay, so this is for number 1. The parse tree. So this is, the parse tree here is going to be straightforward, and the abstract syntax tree. So you have an assignment, and this assignment is, well, you can have an assignment is a statement and the statement list. You can have that. That depends. So it's a statement list and a statement, and that's an assignment. But that really depends on your data structures. So even if you don't put these, that should be fine, because it's a statement list. Okay, and the assignment is you are assigning the identifier to the addition of an identifier and a number. Yeah. Okay, so this is the abstract syntax tree. Now part C we did. It's similar to the sample quiz that we went through. I can post the solution to this. We're not going to go through it now because it's tedious at this point. So we will do number D. So number D, the idea in number D is to get the level of nesting. So the level of nesting is not counting loops. You have to count the level of nesting. So if you are in this while loop, or this is 4, sorry. In this example, it's 4. And then this is there is a condition, and there is a body of the 4. But in the body of the 4, you may have another 4. Right? So the body of the 4 will have a statement list. And in that statement list, there may be another 4. And in that statement list for this, you may have another 4. Okay, but you can have a 4. For example, the body may have a statement list, so you can have all of these 4s. So this is at level 3, right? So if this is level 0, this is level 1, or let's call it 1, 2, 3. But if the body of this loop has another 4, then this 4 will be at level 2 as well. So anyway, so how can we write the actions for this?
Yeah, that's my question.
Yeah, so who did it right?
I don't know if this is correct, but I assumed we could add a max action.
Yeah.
Okay, yeah.
You could get the max of whichever sub-body you were looking at.
Okay, so where do we put the max?
So in this case, if you're looking at the body and you have so let's say, for example, we have,
So let me erase these.
on the if block, since you're going to have multiple bodies in there, you would do the max of the first statement.
Exactly. This is a key idea. Yeah, exactly. So $$ equals max of $1, 2, 3, 4, 5, 6, $6, 7, 8, 9, 10, and $10. Yes. So this is correct. And here, for the 4 itself,
That was just the statement list.
$10 plus 1.
what's that?
$10 plus 1.
Yeah.
Yeah, so the assign doesn't have anything, but this may have 4s in it. So this is the statement list that may have a whole bunch of 4s in it. So we are interested in, again, what's the number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. So $10, whatever, how many for loops are in this, $10 plus 1. So we are adding 1. This is the key idea. So we are adding 1 to whatever the number of for loops in this is. And what else do we need?
You still have to check the statement list.
Okay. Here it's max of
$1,
$1, $2. And what else?
For the statement goes to assignment, you want to set that to 0 because that's your base case.
This is the base case, exactly. So this is recursive, basically. It's, all of this parsing and the traversal of the tree and code generation, all of it is recursive. So you have to master recursion in order to understand this very well. So this is 0. So this is the base of our recursion. And anything else, we don't need anything for the rest of them. And this is just a pass here. Equals $1. And this we will not have anything. So yeah. Well, in fact, a sign equals. So we should put the $sign equals 0 here, but then this will be a pass. $1. Okay. All right. So this is the idea. So how many people got this? Okay. So this is a good number. 6 is a good number. At least more than the people who got the parsing right in the midterm. So this is good. In fact, this is trickier.
Yeah, that is. I wouldn't have thought about max.
Yeah, this is trickier, but that's the idea: is to think about max. So to understand that it's in order to calculate, it's the depth in the tree. But by the way, it's if you have been doing a lot of graph traversals and graph algorithms and analyzing graphs, what we are looking for is the depth below this, but we are only counting the 4s. So we are looking at the depth in the graph, or it's a tree, in fact, and we are counting only the 4s. And whenever you calculate the depth for every node, this is not the depth, this is the height, in fact. The height of this node relative to the leaf nodes, the height of this node is the maximum of the heights. So this is the height of this equals the heights of the children plus 1, or the maximum of height 1 and height 2 plus 1. So this is something that you should have seen in node traversal, in graph traversals and tree traversals. Anyway, so that was an idea.